I'll get started and let the rest come as a little bit late, if possible. My name is Anne-Louise Johansson, and I represent division... Oh, it's difficult to hear. Is that better? Okay, good. I represent division 7, basic and interdisciplinary engineering sciences, here at the Royal Swedish Academy of Engineering Sciences. I would like to welcome you all here today, and I'm happy to see many of you. I hope there will be more coming in. And I'm pleased to present our speaker, Dr. Nasim Farahini, CTO within the area of AI, IoT, cloud. And she comes from Camcom Research and Technology, Stockholm. She has a background in design of custom hardware accelerators, and most recently she comes from Google Mountain View, where she worked on AI systems and IoT cloud platforms. Today she will talk about emerging technology trends, enable intersection of AI and IoT, and the importance of cloud and fog infrastructure. She will also share some insights from her time in Silicon Valley. Before we get started, I just want to mention that you need to use your microphones. This is live streamed, so they are on the side when you ask questions. And also at the end, there will be an IEEE award given to Nasim. Welcome.
Right. Thank you, Anne-Louise, for the introduction. Morning, everyone. I appreciate your coming early in the morning to listen to my talk, and I'll try my best to make it worthwhile. What I want to talk about today is how the emerging technologies of AI, IoT, cloud can be exploited to improve the quality of life, environment, and the competitiveness of Swedish business. I'll start by artificial intelligence. Artificial intelligence simply can be defined as putting human intelligence in machines so they are capable of learning, reasoning, planning, and decision-making. Advanced machine learning algorithms are used to enable such capabilities. But these models need tremendous amount of data to learn by finding patterns in data. And today, this data is mainly provided by IoT. Internet of Things simply can be defined as things that talk to internet. Things such as sensors, smart meters, cameras, and even self-driving cars. It is predicted by IDC that more than 70 billion devices will be connected through internet by 2025. And the generated data volume has reached to unscalable proportions that can no longer be handled manually. On the other hand, AI technology has improved to automate the analysis of such data and extract useful information. Machine learning algorithms are very computation and storage intensive. And this requirement is fulfilled by cloud, which is a centralized high-performance computation platform. Similarly, fog infrastructure provides with computation and storage platforms, but closer to the source of data, or sensors. We are living in a connected world, and the growth in volume of data is phenomenal and is dominated by Internet of Things. Data generated by IoT objects is about 2 exabytes of data every day, meaning billions of gigabytes of data. A jet engine generates 20 terabytes of data per hour. A self-driving car can produce up to 10 terabytes of data per day. More than 90% of the world's data created over the last 2 years, but only less than 1% is utilized today. And here is where IoT and AI meet. And at the merger of these two technological trends, we can think about development of new complex systems and applications that were like dreams a few years ago. Systems such as advanced healthcare. AI can scan through tons of collected patient data, find correlations, prioritize patients with urgent needs, and help doctors to make better diagnosis and plan complex surgical operations. Thousands of sensors will be embedded in houses, in offices, and in cities. And this is going to change the way that we interact with environment. Smartphones most probably will be extinct in near future because environment will be smart enough to understand us by recognizing speech, facial expressions, and gestures. We are installing sensors in remote areas that are difficult or even dangerous for humans to reach, to monitor and automatically analyze environmental changes and make better predictions. It is possible to augment human intelligence and power through collaborations with machines, to make data-driven decisions, to eliminate administrative and repetitive tasks, and free up time for humans to think and to innovate. These technological advancements not only provide us with new services and products, but also they have reshaped the business landscape. In 1999, we see companies like General Motors and Ford that stayed around 50 years among the top 10 companies in valuation. And at the turn of this century, they are replaced by companies that heavily contribute, provide, and exploit the digital data and AI technologies. Sweden has long been recognized as one of the most digitized and industrialized countries in the world. And I would like to share my vision on what Swedish business can do to exploit the emerging technologies and maintain or even further enhance its position. What I want to discuss next is how the four well-known phases in business cycle, which are predict, product, promote, and provide, how can they be adapted and improved by exploiting AI and IoT? And I will provide some examples. A completely new set of opportunities are opened up that were not possible with older technologies. Prediction means accurately forecasting the demand to optimize supply and to optimally shape the future offerings. You can embed tons of sensors in factories, in wind generation farms, in bridges and power networks to remotely collect data and automatically analyze it and analyze data in order to detect anomalies and predict the need for maintenance. This preventive maintenance can increase the profit by minimizing downtime. You can forecast the demand by installing cameras and sensors everywhere in stocks or stores to order only specific quantities of specific products that will sell and minimize the waste. This can be done by finding patterns in shopping trends and anticipating the soon-to-be popular items. Similarly, AI can predict the spread path of viruses and prevent epidemics. Product. Consider example of a product line. We can increase automation by engaging teams of context-aware collaborative robots. In past, we needed to explicitly program robots to bend their joints, twist it, and pick up something in a specific location. But now, with advanced analytics, distributed decision-making, advanced vision sensors, they can be assigned much more complex tasks, like go and pick up something that looks like this. Now, you can integrate them more efficiently with people to work as a team. And this is the new automation approach in factories. Robots can also improve product quality by constant smart monitoring and detecting defects in manufacturing process and improving the yield. All this results in higher productivity and lower cost. It's not only manufacturing and preventive maintenance that benefit, but also marketing and sales aspects. Customer data is streamed through mobile or other distributed devices to internet, helping businesses to understand the state of the mind of the customer and optimize the cost or optimize the price to increase the revenue. Provide. Depending on the nature of the business, the need for servicing varies a lot. But at the end, it means that you customize the service package based on user preferences. That can benefit both the customer and the provider. One category of examples are industrial products, but the other can be services provided by healthcare system. As an example, based on the historical data and real-time monitoring of patient condition, AI can suggest personalized cancer treatment. It also can optimize rehabilitation process for stroke patients by suggesting specific walk patterns. All right, now that we have seen examples of how these technologies, IoT and AI, are impacting the business execution, let's take a step to see how do we implement them and what are the trade-offs that one needs to consider for implementing them. The implementation happens on cloud and fog infrastructural technologies. And there are several variables that can be optimized, like bandwidth, latency, reliability, energy or power, privacy, and security. And given the time that I have, I will mainly focus on bandwidth and latency. But at the end, I will show a slide that presents overall system trade-offs. Let's start looking at the cloud infrastructure. Cloud plays a central role in enabling an integration of AI and IoT by providing a centralized high-performance computation platform at data centers. When the number of connected devices and the demand for computation are modest, this centralized model works. But by sending data to cloud to be analyzed, and by sending control signals back to the edge. But this model has limitations. With proliferation of sensors at the edge of the network bandwidth does not scale. And there are many new applications that need and require real-time action. To avoid an accident in a self-driving car, the action needs to be taken in less than 5 milliseconds. But the round-trip latency to cloud is about 100 milliseconds. So this suggests that if you cannot send the data fast enough to cloud, move analytics to the edge. And this is called data gravity. So we add intermediate processing nodes. And this emerging distributed processing and storage architecture, which is happening like closer to the edge of the network, is called fog computing or edge computing. These nodes enable a fast control loop at the edge by sensing and collecting data, do analytics and inference in gateways, and then sending action signals or control signals back. There will be higher level intermediate nodes as well that can aggregate data and enable machine-to-machine communication. Further, you can filter the redundant data before sending it to cloud. Otherwise, that could cost you a lot. And I will show that by an example. Cameras are very cheap today. Cost of camera, including housing and even additional sensors, is dropping down to almost $5. But if you want to upload all the images that are recorded, it could cost you more than $2 million over the course of 3 years period, which is the lifetime of a camera. You might use advanced image compression methods at the edge to bring this cost down, but still, it's more than 10 times than the cost of the camera. To keep the cost of data in the same range as the camera itself, we need to understand what is going on in the sequence of images. And here is where AI can help with automatic analysis and understanding the image sequences and store only the events that are of interest. Another fascinating example is ingestible imaging capsule that can be swallowed. They even have imaging circuitries and wireless transmitters. They're so small that we can't put batteries on them. They're powered by sound waves. But the interesting question is that how do you distribute the intelligence from things to cloud? Where do you store data? And where do you do processing to filter the data? On device, on gateways, or in the cloud? I'll try to get help from this diagram to explain some of the existing system trade-offs, especially when you want to plan the flow of information and intelligence across the edge to cloud continuum. On one side of this diagram, it's the edge with lots of sensors that produce fast data. We call it fast data because we can act upon it immediately and in real time. But on the other side, it's the cloud with larger storage of historical and global data aggregated from all sensors. And so it's called big data. System responsiveness is reduced by sending data to cloud. But on the other hand, scope of data analysis is reduced by moving to the edge. Scope of analysis is bigger in cloud because you can do global analysis on big data versus local analysis on fast data. Similarly, privacy can be compromised by sending data over the network. And cost of storage and computation is decreasing by moving to the edge, by paying upfront to buy a hardware to do processing on-premise. These trade-offs are not linearly correlated. So you might improve one, but the other one gets worse. So you have to think through and find the sweet spot for your own business. And of course, major companies, major cloud providers are aware of these trends, and they have tried to expand their cloud platform and offerings all the way to the edge. This diagram shows the edge to cloud platform provided by Google. Amazon and Microsoft have similar offerings. Google not only provides services in the cloud, but also has developed cloud IoT edge software platform to manage IoT devices and also to enable lightweight analytics and AI at the edge. They are also providing customers with optimized hardware, Android Things, or Edge TPU to accelerate machine learning at the edge. Edge to cloud is a very complex infrastructure and has many components involved. Huge number of startups have been formed over the last 2-3 years to provide each of these components. Some of them developing optimized hardware products for the edge devices or sensors. Some other developing smart gateways. And some are trying to address the problem of security and interoperability. How can all these components connect and work together? This is one of the main issues, integration of all these components. Right. Let me summarize key takeaways of what I have presented so far. I've tried to explain some of the state-of-the-art applications and functionalities that are enabled at the intersection of the 3 megatrends of AI, IoT, and cloud and fog infrastructure. Based on these technologies, but we have seen many interesting products and services, but they are still in their infancy and opportunities are huge. Another aspect that I would like to talk briefly about is that digital transformation is evolving business models as well. Because new products have embedded sensors that are connected and can be synced, so activities can be coordinated. And so you can not only optimize the performance of individual products, but also you can optimize the performance of the whole farm of products. And instead of selling a product to customers, you can provide customers with services with capacity and performance of connected devices that are working together as a system of systems. Consider the automotive industry. If you're a car manufacturing company and you have the idea of making money by selling cars that are 95% of the time parked in parking slots, your business might be at risk in near future because the competitor might have realized how to combine the autonomous driving technology with smart instant scheduling and provide customers with mobility so they can maximize utilization of the product over its lifetime and monetize even the operational phase. All right, the progress in these technologies is very fast-paced in Silicon Valley. And this is influenced partly by technological aspects, but also cultural aspects. Next, I would like to share the observations that I have made when I worked there over the last 2 years. In Bay Area, you find an extensive collaboration and partnership between major industries, startups, investors, and universities. Education, research, and industry grow hand in hand. Students really get to work on real industrial problems and put their cutting-edge knowledge into practical use and into actual products. Most of the students, when graduate, they already have a product to sell or have an idea for a startup. You extensively see the culture of share and learn, and even working closely with your competitor, because if they have a better product, you naturally need to improve your product as well. There's a high density of talent, investors, companies, and startups. And this has created a kind of a trust in the ecosystem. So if you lose your job, you easily get a new one, like after a while. And if your startup fails, it's not the end of the world. So people take higher risks and do more try and errors, which is an essential component for innovation. High ambitions. You find there high levels of ambitions. Every youngster would like to be the next Steve Jobs, and they work hard toward that. So the question is that how can we improve level of motivation here? Right, and at the end, I would like to talk also about some reflections of unsolved problems related to these technologies, especially AI. These technologies can impact society and industry in many positive ways. But on the other hand, there are some pitfalls to be avoided. The progress is happening fast, and the ethics and regulatory aspects are certainly lagging behind. This issue cannot be addressed by individual organizations or the government alone, but it needs engagements of all stakeholders. First, to understand and define the problem, and then taking actions to solve it. We cannot verify AI models. So how can we certify AI-based products? Who will take the responsibility if something goes wrong? Data provider, model developer, product developer, or the end user? This is an open question. And the last question, but the most important one, is that how can we promote a peaceful and inclusive AI that benefits everyone and represents everyone? AI models are trained by data, and minorities are naturally underrepresented in data, in the existing data. How can we recognize bias in AI models, and how can we avoid them? This brings me to the end of my talk, and thanks again for giving me the opportunity to share my thoughts with you, and I would be happy to take questions.
Do we have any questions? Yes.
Hi, Nazem, Mats here. Firstly, great thank you for this very interesting presentation. Regarding these final topics, there is on YouTube an interesting clips where an AI expert shows a picture of a wolf, but it was registered as a dog by the IA. Then they did backtracking how to arrive at that conclusion, and it turned out that the artificial intelligence procedures were recognizing that in wolves it was always white and snow around it, which meant that it couldn't distinguish a dog and a wolf from each other because there was no snow. And when they did that backtracking, they start thinking, how many other artificial intelligence processors or algorithms are making the similar mistakes, which we not yet are aware of?
Yep.
I like your comments on that.
Yeah, certainly. There are, first of all, they need a lot of data to make sure that these models are trained properly. But and the recent advancements in AI algorithms have been very had very positive impact to reduce the errors that AI models make, but they're still there. So it was 2015 that AI models could be improved so much to be able to compete with human in recognizing images. But in 2018, now they beat human vision. So they are certainly making advancements, but huge there's a lot of there are lots of opportunities for improvements. And as you mentioned, it's very hard to identify or to verify AI models, like how you can make sure that how you can verify that the output is correct. In case of vision, we know the right answer, but in some questions that we don't know the right answer, that becomes a very interesting problem to solve, right? So we are not still there. Yes?
Yes, over there.
First of all, thank you for a very nice talk. Very interesting. Could you elaborate a little on the notion that the AI is not possible to certify against a standard, for instance, because of the black box problem?
Yeah, the problem is again like that AI models cannot formally be verified. So we can say that they are in average. This is the percentage of the error that they make, but we cannot identify which one is correct or which one is wrong in advance. We don't know that. So as I mentioned, this is an open question, and there is a lot of research going on, but it's an unsolved problem.
Yes, please introduce yourself as well.
I'm Johan Schnürer, president or rector for Örebro University. We have a reasonably strong research group in artificial intelligence, and that benefits the engineering students. What would be your advice for the curricula for students in law, medicine, etc., with regard to AI and the things that you just discussed? How should we change our curriculum for the future?
Well, first of all, it's very important that industry and university in this area work very closely, because now AI models or AI in general is used in different application areas to, for example, law or medicine or automotive industry, and many other applications or specific domains. So the real problems are the ones that the emerging problems are the ones that industry can address them first, can recognize them first. So I think it's very important that universities and industry, they work together to set the curriculum, because we also have shortage of talent, and we have to make sure that there are enough people with specialized expertise that can fulfill the demand. And specifically about medicine or law, I think privacy is one of the main issues, and regulatory agents need to solve that problem. I don't think that is something that students can address, but there are many interesting problems like cancer treatments or drug discovery using AI, or recognizing bias in a document, in a legal document. These kinds of things can be addressed. Hopefully, students are educated enough and in right direction so that they can solve these kinds of problems.
We have a question over there.
Right, thanks again. My name is Ulf Kruse. I'm chairman of the Chamber Business Networks. Now, a question for you. I believe that AI is very much a playground for businessmen and technology people right now, engineers. So that leads us to regulations. And there are a number of initiatives, one led by Max Tegmark at MIT, for highlighting those issues. Can you expand and elaborate on, can it be regulated, and by whom? Is that G30, is it United Nations, or who will regulate that?
Let me make sure that I heard and understood the question correctly.
How do you regulate AI, and who should do it?
Yeah, so that's a good question, but general one. There are many regulatory aspects. For example, privacy of data. If we do not share data, the AI growth can be compromised. But on the other hand, if we share data, privacy might be a problem. So this, I think, needs revisiting the regulations and laws to address these kinds of problems.
I think the least concern is the data. We're talking about decision making by computers for us. That is the concern.
Yeah, that's
how
also
do you regulate that?
true.
Because it's compared with nuclear power, atomic bombs, similar.
Yeah, no, that's very true. And recently, Google has invented a tool that AI models can generate AI models, the optimized ones that can generate best AI model to solve a specific problem. So that's true. This is a valid concern, and we need to start thinking about these aspects to avoid future pitfalls. But at the same time, it's important to realize that strong regulations can limit the innovation. So we really need to find a balance, find the right balance.
Any further questions? Yes, please.
Yes, thank you also. My name is Halvard Johansson, a former executive of the Electrolux Group. And I like to know a little more about your last point here, to avoid that this will be a money's game, for example, the defense industry or the rich people and so on, are the only one who benefits of the AI.
Yeah, so definitely. I mean, AI models, as I mentioned, are trained by data, and it's very important that we start thinking about, engaging everyone, engaging data from all parts of the world, from different races or different types of people, so that AI models can represent everyone. And I think the most important problem is that we cannot identify if this model is biased, or how much data we need to make sure from each part, we need to make sure that this bias is removed. And of course, we would like AI to advance technology that is available and accessible by everyone, not only, as you mentioned, by only rich people. So, that's an important aspect to think about. But these all are still open questions. So I don't know the answer, and I guess no one knows the answer. So we all need to have them in considerations and discuss them openly to attract attentions and to define problems and to solve them.
Any more questions? Yes, please.
Thanks. I have a question about behavior changes for companies changing our behavior quite a lot.
Could you clarify what type of behavior? What type of behaviors?
That the company is more in control of our behavior in a way that I think is hard for people to understand how it changes. It was, I think it was easier before with the commercial how it changes, because it could we could understand it better, but it's more and more hidden. I think the more data that is being analyzed and more things going on in the background.
Right, that's true. So yeah, when data is available, lots of aspects that we can't even think of, lots of information can be extracted out of it, and progress in this area has been very fast, but still a lot of like new everyday new applications are popping up, and as you say, like we receive a service and we enjoy it, but we don't know that the technology behind that. Since the progress is so fast, maybe we cannot catch up with all these changes or all these technological aspects that are creating new services and products for us that we are using daily. And specifically about AI, they are by themselves like black boxes. There is no mathematical model behind it yet. So there is a black box. You train it with a lot of data, and then that starts working, right? So by nature, you don't understand like how this nonlinear function can generate this specific output from a specific input. And they themselves, they cannot explain it or interpret the output yet. This is, again, one of the one of the advanced research problems that researchers are trying to solve, interpretability of AI. So if it makes a decision, or if it generates an output, why it has made that decision, that is an unsolved problem. Yes.
On the note of the artificial intelligence and the fact that today humans have to program all the computers with information, and the note that suddenly the computers will start programming themselves, so it will be a self-fulfilling way of getting forward. But what do you believe are the limitations to AI? That is, what will they not be able to do to copy the human thinking? Is it the abstract thinking, or do you think they will get to that point as well? Or where are the, well, limitations in the longer run?
I think that's a very good question. And I guess it's important to think about this aspect, start thinking about this aspect right now. But I guess we are still far from it. AI models today are very far from a general AI that can solve any type of problem. They are very specialized to solve specific tasks. But that's also a difficult question to answer. What type of problems they eventually cannot solve? The progress is fast, and they are improving day by day, but they are still very far away, from the way that human can think and make decisions. Everything is just based on data.
We have a question over there.
Yes, hello. My name is Oscar Nordmark. I'm an engineer working with data science and algorithm development. Just before this presentation, I had started having a discussion about intellectual property rights. And in my line of work, I've been writing some patents and working with intellectual property rights. And this is also an important business case for a lot of companies. And what's your view and experience on how intellectual property rights should be and applied to AI, and if it's desirable?
Mm-hmm. I guess when you're talking about intellectual property is because of AI is because there are many agents involved, like someone who develops the model, someone who provides the data, because their AI models without data can really do nothing. And when they put them in a product, so who, I mean, how this intellectual property works. I am not specialized in this area, so I don't think that I'm the best person to answer this question. Yeah, I guess it, yeah, tricky.
To clarify my question a bit, I'm curious about if in your experience, people want this in some way, if they think it's too little regulation regarding it, if they want to continue keeping it as a business case for companies as well.
Yeah, that's true. I think one of the things that I can mention is that I really don't have experience with this, because there are still like not many discussions around it, or the regulations are still not there. So it needs more discussion, and we need more regulations around it. So AI products are now more AI products are developed day by day, and they are being put in different products, but how these IP regulations are handled, I think it also needs more attention. And as I say, I don't have a personal experience with it.
Then we have another question over there.
Yes, I'm Martin Liden from the PRV, Swedish Patent Office. I could just comment. We had this discussion during the coffee break before. I can just say briefly that there is a discussion going on internationally between all the patent offices of the world right now. I mean, it's a very big challenge, of course, both to look at who would actually have the ownership and rights to what is accomplished by AI, but also other aspects such as how do we define inventiveness, who will be the inventor, and what will be inventive step, where when AI is actually the inventor, you know, and the skilled person in the art, as we define him, will also have access to AI. So that's also one aspect that's discussed, and possibly we will see development also where we will have to manage practice in all fields of intellectual property, but also we might need to look at new forms of rights, new intellectual property rights, which are better adapted for this type of technology. But that's just speculation at the moment. Yeah.
No, that's very true, and I agree with that.
Okay, Mats, you had a last question?
Yes, one question very much related to that one. We have the IPR issue, but we also the responsibility. Let's suppose that here is an autonomous vehicle working in an industrial area, and something goes wrong, and something gets, has impact on the very product of that industry, and somebody get injured. And then you send in the lawyers. Who is responsible for what? And everything was, say, at the edge, or maybe clouded, but or a combination.
Yeah, that is a lot of discussions are going around this, and some of the discussions are that they argue that probably government should take care of these kinds of should take the responsibility of these kinds of problems that has many technological aspects and parties involved. But these are all regulatory aspects that are lagging behind, and we need to discuss them today.
Just that one. And since this is a global net, so which jurisdiction, which government, and where is so what when discussing with legal people, said it will be very complex. But do you have any inputs? I know this is a very tricky question.
Yeah, that's a tricky question, and no, I think there are many discussions around it, but not a specific solution that I can talk about.
Yes. Last comment there, and then we need to close.
Yes, thank you. My name is Mikael Hjalmarsson, working for SIS, the Swedish Standards Institute, and you mentioned standardization earlier in your presentation. Which areas do you foresee that we need to focus on within the standardization when it comes to AI?
Standardization is... But that's a tricky question, so no short answer. So standardization of what aspects do you mean specifically?
I mean, that's really the question. Which areas do you foresee is what we need to focus on when it comes to standardizations to overcome the open questions you have raised here? Mm-hmm. For example, for certification, you have ethics and regulations that needs standards to be able to do the compliance and so forth. And it's
yeah, I guess the aspects of, for example, privacy needs some standards. I guess some of them are covered already in the discussion. Responsibility, certification of like AI products, like data standards. Yeah, but I guess like we need to define metrics to be able to compare these AI models and results. And those are still not there. So I guess the first question is that we need to define those metrics.
And with that, we'll end. And before we end, finally, give Mats Edvinsson the chance to, he wanted to use this opportunity to hand over an IEEE Global Award. And he comes from the IEEE Sweden section. So please.
Is there a slide? Today I'm here representing IEEE. It's an international organization, 160 countries, 423,000 plus members. Founded 1884 by two gentlemen, one was Graham Bell and Odd Edison, who thought electricity was interesting, let's form an organization. And Nassim is a member, and I'm here now to be very proudly to present a Global IEEE Award for outstanding work for women in engineering in Sweden. So this is a recognition. You've been in Silicon Valley, so this is the first time I'm able to hand it over to you. So congratulations.
Thank you. Thanks, Matt. Thank you.
Next slide. And this is just to put things in perspective. Among the members, there are some who have received some other awards. And Hiroshi Amane, he was here at IVA last, it was on 20th of September. So.
Yeah, thanks a lot. Thank you.
And here's an envelope.
Thanks.
Thank you.
Thank you. Thank you, everyone.
So thank you, everybody, for coming. And thank you, Nassim, a little present from the Academy.
Thank you.
Thank you. Have a good day.
Thank you. Thank you.
Keep it to 6.